Number 4, solve the equation by using the quadratic formula. So if we're solving to solve ax squared plus bx plus c equals 0, one approach you can use is the quadratic formula, which says x equals, the solution equals negative b plus or minus, because there's two solutions, b squared minus 4ac, everything over 2 times a. So I'm using this formula. In this problem, let's see, a equals 3, coefficient of x squared, b equals 12, coefficient of x, and c is my constant, negative 15. So I'll rewrite the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm just substituting these values in and doing the arithmetic. Negative b is 12, plus or minus square root of b squared, which is 12 squared, minus 4 times a, which is 3, times c, which is negative 15, everything over 2 times a, which is 3. X equals negative 12 plus or minus the square root of 12 squared, that's 144. Let's see, 4 times 3 is 12, right? And 12 times 15, what does that give us? That's 180. So plus 180. All over 2 times 3, which is 6. Let me erase this little extra. Yeah, get rid of that. Okay, continuing. X equals negative 12 plus or minus the square root of 144 plus 180. What is that? That's 3, 2, 4. All divided by 6. Okay, now we're looking at something here. Negative 12 plus or minus. Now 324, to me that sounds like a perfect square, doesn't it? 324? What square gives me 324? I'm thinking. I think it's 18. Square root of 324 is 18. Divided by 6. Let's keep going. X equals, so there's two solutions here, right? Here's one solution. Negative 12 plus 18 over 6. That's one solution. Here's the other solution. X equals negative 12 minus 18 over 6. That's that plus or minus. So x equals, here's 6 divided by 6, which is 1. The other solution, x equals negative 30 divided by 6. X equals negative 5. So I've got two solutions here. X equals 1, and x also equals negative 5. It's really hard to do braces and things like that with this tablet. Again, don't judge me. These are my two solutions. X equals 1, x equals negative 5. Another thing, since these are rational numbers and they're whole numbers, that leads me to believe two things. One, that this original quadratic was factorable. Not only was it factorable, take a look at this. I have a greatest common factor in here of 3 that I can factor out. See that? Divide by 3, that's 4x. Divide by 3, that's 5. Equals 0. And I can factor here again. This is plus 5 minus 1. And if 3 can't equal 0, so that's out. X plus 5 can equal 0. Zero product property, right? If this times this equals 0, then one of these factors has to equal 0, or both. So I got x equals negative 5, and x equals 1. So this was factorable. They asked us to use the quadratic formula, so we used that. But we got the same solutions as here when we factor, because this was factorable. And we did that magic.